Chip industry latest news. NITIIX Frontier Tech Hub has released a report titled Future of India's Semiconductor Industry, highlighting the challenges and strategic imperatives for building a globally competitive chip manufacturing ecosystem in India. About semiconductors. Semiconductors, commonly known as chips, are materials that conduct electricity better than insulators but not as well as conductors. They form the foundation of modern electronics and are found in virtually every electronic device, including consumer electronics, smartphones, laptops, televisions, and home appliances. Automobiles. Modern cars contain hundreds of chips for engine control, infotainment, and safety systems. Defense equipment, missiles, radars, satellites, and communication systems. Industrial machinery, robots, automation systems, and IoT devices. Healthcare devices, medical imaging, diagnostic equipment, and wearables. Stages of semiconductor manufacturing. The semiconductor value chain comprises several stages. Design, creating chip architecture and circuits. Fabrication, fabs manufacturing the actual chip on silicon wafers in highly specialized facilities. Assembly, testing, marking, and packaging, ATMP final stages where chips are packaged and tested before shipment. Fabrication is the most capital-intensive and technologically complex stage, requiring ultra-clean environments and specialized equipment costing billions of dollars. India Semiconductor Push. The Union government launched the India Semiconductor Mission, ISM, with a corpus of 76,000 rupees crore to develop a robust semiconductor ecosystem. The mission supports semiconductor fabrication units with capital subsidies of over 50%. Display fabs for manufacturing display panels. Compound semiconductors and packaging facilities. Design-linked incentives for chip design startups. Bulk subscriptions to industry-grade semiconductor design applications for students and academia. Current status. India does not yet have a single operational fabrication unit. The first fabrication unit is expected to begin operations in Dholera, Gujarat by 2028. A total of 10 semiconductor projects are in various stages of development. Multiple semiconductor packaging and testing facilities have been approved with significant subsidies. Key findings of the NITIIX report. India's current ecosystem is not self-sufficient. The report explicitly states, India's local ecosystem is not ready to fully meet domestic demand for semiconductors. Even chips used in domestic electronics assembly are largely sourced from outside the country. National security imperative. Many semiconductor parts used in defense systems are produced outside India. This creates threats to national security as India deploys foreign chips in aerospace and defense programs. Geopolitical disruptions, such as a potential disaster in Taiwan, which dominates global chip manufacturing, could massively disrupt the global electronics supply chain. Long gestation period. Fabrication units typically require 4 to 5 years before commencing production. Investment in 50+ specialized equipment from global players is required during the gestation phase. Yield optimization and reliability testing take several quarters even after production begins. Talent development for semiconductor fabs is similarly time-consuming. The sector requires sustained, mission mode commitment over a decade or more, the report states. Strategic recommendations. Building sovereign capabilities. Sovereign design and research capabilities to reduce dependence on foreign IP. R&D excellence in materials sciences and silicon design. Harnessing agentic AI for semiconductor engineering. moving from a services-led design base to becoming a creator of differentiated IP, architectures, and integration technologies. Capital investment requirements. The report estimates the necessary capital expenditure from the state at $45 to $60 billion over a decade for the second phase of the India Semiconductor Mission, ISM 2.0. Strategic focus areas. Away from frontier chips, 3 to 7 nanometer transistors, where risks are very high. Towards mature and advanced nodes aligned with strategic relevance. Focus on compound semiconductors for defense and industrial applications. Emphasize selective depth, capital efficiency, and system-level differentiation rather than attempting to replicate the full global manufacturing spectrum. Packaging as a core pillar. The report identifies chip packaging, traditionally seen as a downstream activity, as a core production pillar. Less expensive and complex than fabrication. Can enable rapid import substitution in high-volume domestic segments. Provides a strategic entry point into the global semiconductor value chain. Trusted partners strategy. The report outlines a strategic partnership framework for India's semiconductor ambitions. Priority partners. The report highlights the following nations as trusted partners: the United States, Japan, the European Union and South Korea. Areas of collaboration. Cooperation with these partners would provide access to critical tools, equipment servicing, and life cycle support. Leveraging India's market scale, talent base, and packaging capacity. Joint research and development opportunities. Technology transfer arrangements. China as an adversary. The report implies that China remains an adversary in chip-making despite recent diplomatic thaws between the two nations. This reflects the broader geopolitical realignment in the semiconductor industry, where Western nations and their allies are seeking to reduce dependence on Chinese supply chains. Challenges facing India's semiconductor industry. Capital intensity. Setting up a single fab requires billions of dollars in investment. High operational costs and long payback periods deter private investment. Need for sustained government support over decades. Technology gap. India lags significantly behind established semiconductor manufacturers like Taiwan, TSMC, South Korea, Samsung, and the US. Lack of indigenous process technology and IP. Heavy reliance on foreign equipment and expertise. Talent shortage. Shortage of specialized engineers with semiconductor manufacturing experience. Need for comprehensive training programs and educational reforms. Competition for talent with established global semiconductor hubs. Supply chain dependencies. Dependence on imported raw materials, chemicals, and gases. Need to develop a domestic ecosystem of suppliers. Vulnerability to geopolitical disruptions. Infrastructure requirements. Need for reliable power supply, ultra-pure water, and specialized gases. Requirement for clean room facilities with stringent environmental controls. Long lead times for setting up support infrastructure. The semiconductor industry in India is in focus as Prime Minister Narendra Modi recently inaugurated an OSAT, Outsourced Semiconductor Assembly and Test, facility in Gujarat, highlighting India's growing role in the global chip ecosystem. State of semiconductor industry in India. India's semiconductor market is valued at around $45 to $50 billion in FY 2024 to 25 and is projected to grow significantly in the coming decade. The sector is expected to reach nearly $120 billion by 2030 and $300 billion by 2035, driven by demand from electronics, automotive, AI, and data infrastructure. However, India still relies heavily on imports, meeting more than 90% of its semiconductor needs from abroad. This dependence is expected to decline gradually as domestic manufacturing capacity expands. At present, India is developing its semiconductor ecosystem through investments in fabrication units, fabs, compound semiconductors, and assembly and testing facilities. Alongside manufacturing, India has emerged as a strong hub for chip design, with global companies increasingly undertaking advanced R&D work in the country. Opportunities shaping the growth of India's semiconductor market. Rising domestic demand. The rapid expansion of smartphones, electronics manufacturing, electric vehicles, and digital services is creating sustained demand for semiconductors across sectors. AI, 5G, and data center expansion. The growth of artificial intelligence, rollout of 5G networks, and increasing investments in data centers are driving demand for high-performance and specialized chips. Global supply chain diversification. Geopolitical uncertainties and disruptions in traditional semiconductor hubs have encouraged companies to diversify supply chains, positioning India as an alternative manufacturing destination. Strong design ecosystem. India's established base in semiconductor design and engineering talent provides a competitive advantage in moving towards high-value segments of the value chain. Employment and investment potential. The sector is expected to generate large-scale employment and attract significant investments, with multiple projects already approved and more in the pipeline. Initiatives to promote India's semiconductor industry. India Semiconductor Mission, ISM 1.0. India Semiconductor Mission, ISM 1.0 was launched in 2021. It aims to build a strong semiconductor and display ecosystem, positioning India as a global hub for electronics manufacturing and design, while serving as the nodal agency for the efficient and seamless implementation of semiconductor and display schemes. With a large financial outlay of 76,000 crore, ISM 1.0 laid the foundation for semiconductor manufacturing by providing up to 50% fiscal support for fabs, packaging units, and design initiatives. India Semiconductor Mission, ISM 2.0, 2026 announced in the Union Budget 2026-27, ISM 2.0 marks a shift from capacity creation to ecosystem deepening. It focuses on domestic production of semiconductor equipment and materials, development of full-stack Indian intellectual property, and strengthening supply chains. It also emphasizes industry-led research and training centers, with a budgetary allocation of 1,000 Indian rupees crore. Electronics Components Manufacturing Scheme, 2025-26 expansion. The government has significantly increased the outlay for component manufacturing to strengthen the upstream ecosystem, reduce import dependence, and support semiconductor manufacturing. Design-Linked Incentive, DLI, Scheme. This scheme supports startups and MSMEs engaged in chip design by providing financial assistance and access to design infrastructure, encouraging indigenous innovation. Production-Linked Incentive, PLI, Scheme. PLI schemes for electronics and IT hardware promote domestic manufacturing and create demand for semiconductors within the country. Infrastructure and Cluster Development, schemes such as SPECS, Scheme for Promotion of Manufacturing of Electronic Components and Semiconductors, and Electronics Manufacturing Clusters, EMC 2.0, focus on building infrastructure and strengthening the electronics ecosystem. Chips to Start Up, C2S, Program. C2S is an umbrella capacity building program initiated at academic organizations spread across the country to generate 85,000 number of industry-ready manpower at B.Tech, M.Tech, and PhD levels specialized in semiconductor chip design. Global partnerships and investments. Strategic collaborations with global companies and countries are facilitating technology transfer, investment inflows, and integration into global semiconductor value chains. For example, India has seen major global engagement with Micron Technology and Kane Semicon setting up advanced semiconductor facilities in Gujarat Sanand under the India Semiconductor Mission, linking domestic manufacturing directly to international markets. At these plants, products such as intelligent power modules are being exported to global customers, strengthening India's role in global supply chains. Challenges. The growth of India's semiconductor industry, while promising, is accompanied by several critical challenges that need to be addressed to ensure sustainable development and global competitiveness. High capital and technological barriers. Semiconductor manufacturing requires extremely high investment and advanced technology, making entry difficult for new players. Import dependence and limited indigenous IP. India continues to depend on imports for chips, materials, and intellectual property, limiting technological self-reliance. Skill gap. There is a shortage of highly specialized workforce required for fabrication, packaging, and advanced semiconductor research. Global competition. Established players such as Taiwan, South Korea, and the US dominate the semiconductor industry, making competition intense. Infrastructure and policy constraints. Reliable power, water, logistics, and efficient regulatory systems are essential but still evolving in India. Environmental concerns. Semiconductor manufacturing involves high energy use and hazardous materials, raising sustainability challenges. Way forward. India must adopt a long-term and integrated strategy to emerge as a global semiconductor hub. Strengthening research and development, promoting indigenous intellectual property, and building advanced manufacturing capabilities will be essential. There is also a need to expand skill development through industry-academia collaboration and specialized training programs. Policy stability, faster clearances, and better coordination between the center and states will be crucial for attracting investments. India should leverage global partnerships and focus on niche areas such as semiconductor design, compound semiconductors, and advanced packaging. With sustained policy support and execution, India has the potential to transition from a major semiconductor consumer to a key player in the global semiconductor ecosystem.